So solving quadratics by taking the square roots. There was a lot yesterday, so let me find the solutions. All right, does anybody want me to go over any of those in particular? Yes, good for you. 28. Let's look at 28. Right here, correct?
Yes.
How's that?
Good.
Anybody else have a question? Now again, the graphing quadratics really is just a good review that I want you to take a look at. Make sure you understand how to graph those. Those are really important. Anybody else on this worksheet? Anybody else have a question? Everybody's good? All right, perfect. Now, today, listen, I said a few minutes ago that today was a little harder. It's not that it's harder, there's just, normally in math I try to show you the logic behind it, and I don't really think you would understand this logic without someone explaining it to you, all right? And it's usually like a three-part step, 3 steps to this. We call solving quadratics by completing the square, all right? In other words, you're taking a quadratic and making it a perfect square, and then you can take the square root, all right? Because you can't take the square root of an x squared if there's an x term also. All right, so let me show you exactly what I mean by that. And again, I don't think it's necessary to write the steps because once we do it 20 times, you'll have it in your brain. But right now, you got to listen carefully. All right. There's also some problems with fractions sometimes, so it's a good day to review and make sure that you understand everything there is to know about fractions. So with that in mind, here we go. Solve by completing the square. Now, what I want to do is, I also try to tell kids that I would never ask you to do something more difficult, because if I was asking you to solve number 1, it wouldn't be by completing the square, it would just be by what? Factoring. Come on now, you got to really listen today. You got to really listen, it's different. All right, so when you take a test, if I say solve, I'm not going to say any particular way, right? But in this case, I'm going to show you how to solve it a harder way just to show you the process. All right, let me show you, see if you understand what I mean. If I was doing this 2 weeks ago, we would just factor it, and we'd say this is a plus 3 times a minus 1. So a plus 3 equals 0, a minus 1 equals 0, so a is negative 3 or a is 1. So remember that? Basic just factoring, set the factors equal to 0. Everybody okay with that? So that would be the answer. That's how I would want you to do it. All right? But today we're going to solve it by completing the square. Now, the reason we're doing that is because when you take Algebra 2, there are certain things that you have to solve by completing the square. You can't do the problem. So the process is really, really important. And again, sometimes it overlaps because I would want you to just factor that. Does everybody understand what I mean? But today I'm going to show you how to do it a little bit more difficult way just because it's learning the process. All right? So step number 1 when you're completing the square. First of all, the leading coefficient has to be a 1. All right? That has to be a 1. All right? The next step is this constant has to be moved to the other side. So right now you're going to write a squared plus 2a, leave a space, equals 3. All right, now here's where completing the square comes in. To complete the square, it's always half of the middle term and then squared. So what is b in this case? 2, right? So 2 divided by 2 squared, what does that equal? 1, right? So you're going to add 1 to both sides. Now, this right here is now called a perfect square, all right? Why is that a perfect square? Because it can be factored into a plus 1 squared equals 4. A plus 1 squared equals 4. Now, I always try to teach kids that it will always factor into whatever the half was. See that 1 there? That will be the answer here, positive 1. It always factors into whatever the half was. All right? Now, just to make sure you're understanding what I'm saying, if I did a plus 1 squared, what would a plus 1 squared be? Very good. A squared plus 2a plus 1. You have to understand that. Does everybody understand that?
Yeah.
Everybody okay? All right? So this becomes a perfect square. All right, so it'll always factor to whatever the half was. All right, now I'm going to move this out of the way. Now you should recognize this is where we were yesterday. So once you get to this step, now you should know what to do. What am I going to do to both sides, guys? Take the what? Yeah, I'm going to take the square root now. When you take the square root of a square, what happens? Cancels. So this becomes a plus 1. Now let's see who remembers. A plus 1 equals what?
2.
Nope. What does a plus 1 equal?
16.
Thank you. Wow. Plus or minus 2. All right. When you take the square root of a square, it's plus or minus. Now I subtract 1. So a equals negative 1 plus or minus 2. Which means a is equal to, if I say negative 1 plus 2, what's that? 1. Or if I say negative 1 minus 2, what is that? Or a is equal to negative 3. Is that the same answer?
Yeah.
Yeah, same answer. So which way is easier? Obviously by what?
1.
Factoring. We would just factor that. But I'm teaching you a process. So I have to give you easy problems to start out. So everybody understand that? Or it's just a different technique. Tomorrow we're going to learn a new technique on how to solve quadratics. All right? So there are 3 techniques to solve a quadratic. You just have to figure out which one's the easiest for you. You can't always factor. And when you can't factor, you have 2 other choices. All right? So hopefully you're okay with that. All right? Now let's look up here. Number 3. Are there any factors of 22 that make 16? So this one, guess what? It doesn't factor. It doesn't factor. All right, so in the past, we would just write prime. All right, or on a test, you would never have this. All right, because you can't solve it by factoring. All right, well, not everything factors, but there is still a solution. So, first step, p squared plus 16p is equal to what? Is equal to 22. Now you take half and square the middle term. What's b? 16. What's half? Squared, which is 64. Perfect. So now I put a plus 64 and a plus 64. Now, somebody tell me, what does this factor to? It always factors to? Very, very good. P plus 8 squared equals what? 86. Now what do I do? Come on, guys. Take the square root. Come on. So P plus 8 is equal to what?
P plus 8.
Plus or minus
Plus or minus.
square root of 86. So P is equal to what? Does the square root of 86 break down? No, because it'd be 2 times 43, and 43 is prime, and 2 is prime, so. All right. Is everybody okay with that? Anybody have any questions with that? Don't worry about it. Just sit down and hurry up. Thank you. You're behind. All right. So I want you to listen carefully now for number 5, all right? Anybody have any questions? All right, same process.
Where did you get the 86 from?
Did you add 22 plus 64? All right, here we go. Question number 5. Question number 5. Here we go. Same process. I move the negative 33 over, and that negative 33 becomes positive 33. So I want everybody to write down r squared plus 2r, leave a space, equals 33. So when you take half and square, so 2 divided by 2 squared equals what? 1. What?
Why'd you do 2 divided by 2 squared?
Because that's always the rule. You take half and square the middle term. All right? Which is b over 2 squared. You with me? So that becomes a plus 1. And then I put a what? Plus 1. Now, what does r squared plus 2r plus 1 factor to? Tell me.
R plus 1 squared.
Come on, guys. I need someone else. R plus 1 squared is equal to what?
Radical 34.
No.
Plus or minus.
No. R plus 1 squared is equal to 34. Step by step, guys. Now we have to do what? Take the square root, right? So I end up with r plus 1 equals, now you can tell me,
Plus or minus that. 34.
plus or minus the square root of 34. Now to finish it off, it's just going to be r is equal to negative 1. Beautiful. Just like that. All right, so there's 3 examples. Let's just continue on. All right, here we go. One more time now. All right, solving by completing the square. The constant has to go to the right side. So we write down m squared minus 12m equals negative 26. Now to complete the square, you always take half and square the middle term. What's half of negative 12? Squared. So this would be a plus 36 plus 36. Now sometimes it's easy if you put this step in here, right? But most of you can, all right? So now, factoring it becomes what? Be careful, please. What does that factor to? M minus 6 squared this time. M minus 6 squared equals what? Beautiful. Now what? M minus 6 equals
Plus or minus radical 10.
plus or minus radical 10.
Plus 6.
That's right.
Equals 6 plus or minus radical 10.
Very good. M equals 6 plus or minus radical 10. Virginia, you get in there? All right, let me know if you have a question. Any questions now? All right. Go ahead. Everybody try number 9 real quick. Let me see if you can do it by yourself. Look up, see how you did. Hey, let's go. Hurry up, because I got a lot to show you. Is everybody okay with that? Everybody okay? Now, because these did not have any radicals in the answers, I could have done what to this problem right here? Factored it. Listen to what I'm saying. All right, if there's a radical in the answer, you couldn't have factored it. Is everybody with me? All right, because it worked out to be 12 or -4, you could have factored it. Any questions? All right, let's try number 11. Since we have someone new walk in the door, let's go slow for him. All right, so again, solve by completing the square. You want to isolate the square and the x term. So I have to move -48 to the other side. You with me, Patrick? We're on number 11. So I add 48, which brings me to m squared plus 2m equals what? 42. Perfect. All right, you with me? That's kind of step 1, Patrick. Now, to complete the square, you always take half and square the middle term. 2 divided by 2 squared equals what? 1. You with me, Patrick? So I took half of this and squared it. So I add 1 here, and I add 1 here. The reason why we do that is because now this becomes what's referred to as a perfect square. That becomes a perfect square. So that's easy to factor. It always factors into whatever the half was. That becomes m plus 1 squared equals 43. You with me? Now we take the square root. Take the square root. M plus 1 equals plus or minus the square root of 43. So m is equal to -1 plus or minus the square root of 43. All right? Okay, here we go. Do a couple more. All right, 13. M squared plus 10m, leave a space, equals -21. When you complete the square, it becomes what? Plus 25. Plus 25. Factors to what now? Thank you very much. M plus 5 squared. All right, we'll go slow for you. See, the middle term is 10. You always take half of that, and then you square it. What's half of 10? Squared. That's where the 25 comes from. That's how you make it a perfect square. All right? Every time. All right, now we take the square root. M plus 5 is equal to what? Plus or minus 2. So M equals, in this case, you tell me what's negative 5 plus 2, or, yes. There we go. Everybody okay with that? Patrick, you catching on? All right, number 15, I just made it a little confusing by putting it out of order. So everybody here is smart enough to say 5v squared minus 10v, leave a space, equals 21. Anybody have any issues with that? Anybody have any issues? Now, what's the problem now? Has to be 1. The leading coefficient has to be a 1. So the problem I have right now is this 5. Is everybody with me? So now how do I make that a 1? Yep, that's all you have to do, guys. Divide by 5. So divide by 5, divide by 5, divide by 5. So now I have v squared minus 2v, leave a space, equals, now we're going to work on our fractions, 21 over 5. Now, when you complete the square, what am I getting? You're adding what? 1, thank you. Plus 1, plus 1. Now, what does it factor to? V minus 1 squared equals. Now, 21 fifths plus 1. Everybody should be able to. 26 fifths. Beautiful. Now, how do we know that? We know that because 1 is the same as 5 fifths, just to make sure. Everybody good? Any questions? Any questions? All right, so now you got to be careful. We got to take the square root. Now we take the square root. I have v minus 1 equals plus or minus the square root of 26 over the square root of 5. Now again, we're going back to before spring break when we had a little test on radicals. You're not allowed to have a radical in the denominator, so you have to multiply the top and bottom by radical 5. Beautiful. So now I have v minus 1 is equal to plus or minus the square root of 130 over 5. Anybody have any objections to that? Now I have to do what? I have to add 1 to both sides. When I add 1, I end up with v is equal to 1 plus or minus the square root of 130 over 5. Now, this is not generally how we leave it. We're going to get a common denominator. So 1 is how many fifths? 5. So now watch, please. 5 over 5 plus the square root of 130 over 5 is the same as 5 plus or minus the square root of 130 over 5. If you leave it like this, I don't have a problem. But this right here is the best answer. That's the best answer. All right? Any questions? All right, let's take a look at 17. What do I need to do on 17? Yes, divide everything through by 7. So b squared minus what? 2b equals what? 8. Everybody okay with that? Now when you complete the square, you get plus 1. Plus 1. Factors to what? B minus 1 squared equals 9. So B minus 1 equals plus or minus 3. So B equals 1 plus or minus 3. So B is equal to what? Negative 2 or 4. All right, anybody have any questions? All right, now 19 I think is the last one. All right, and it's the hard one. All right, the reason why it's a hard one, it's not really that hard, it's just that there's fractions, more fractions. All right, so we're really just going to practice the fractions before our ERBs. Make sure you remember everything you need to know about fractions. All right, please stay with me. N squared plus 5n equals what? 5. All right, now you got to pay attention. Now when you complete the square, it's 5 over 2 squared. What's 5 over 2 squared? Beautiful. 25 over 4. All right, just squaring them individually. Plus 25 over 4. Everybody okay with that? Now, here's where people make mistakes. That's no different than what we were doing before. So it always factors to the what? Whatever the, come on, it always factors to whatever the half was. It always factors to the half. What was the half? 5 over 2. So this now becomes n what? Plus 5 over 2 squared equals, I don't think so. I think 45 over 4 is good. 5 is 5 over 1. 5 is how many fourths? 20. 20 plus 25. Come on now, you got to be that good at the fractions now. Is everybody okay with that? You're adding fractions, you need a common denominator. Anybody have any questions with 45 fourths? What?
I'm confused why you did 25. How did you get from 25 over 4 to 5 over 2?
No, I didn't. 5 over 2. Just come on, let people ask. All right? This is just a result from taking half the middle term. You with me? It had nothing to do with this addition problem over here. You hear me? All right. Now again, are you okay with 45 fourths now? All right. Anybody have any questions with adding fractions? All right. Now, when I take the square root, here's what I want you to be able to tell me. N plus 5 over 2 equals, I'm hoping you can say this, plus or minus 3 radical 5 over 2. Anybody have any questions with how it's 3 radical 5 over 2? Because I'm taking the square root of both sides, right? What's the square root of 45? 3 radical 5. And what's the square root of 4? All right, perfect. You're in good shape if you know that. So n is equal to, now see if you understand this, -5 plus or minus 3 radical 5 all over what? 2. Do the fractions already have a common denominator?
Yeah.
So I can just add the what?
Right.
Add the numerators. The problem is, can I add a radical?
No.
No, you cannot. So that's why that's the answer. -5 plus or minus 3 radical 5 over 2. Now, just an example. Look up, please, one more time. Last thing before I let you go. If this was a 5, can I reduce the two 5s? Definitely what? Anything bounded by addition and subtraction, can you reduce? Never. You cannot reduce. If that was a 5, you can't cross out the 5s. Is everybody with me? If this was, for example, a 10, could I reduce now? Yes, because everything is divisible by what? 5. All right? Hopefully you understood what I meant there. All right, but I'm just going to backtrack here, and that's my final answer. All right, does anybody have any questions? So now, generally when you're doing solving by completing the square, you decide if you're going to do it by completing the square or by quadratic formula, which I'm going to show you tomorrow, depending upon what the middle term is. If the middle term is odd, it's just annoying because it's involving what? Fractions. If the middle term is even, that means the problem is what? Easy. All right? Because when you divide an even number, you get a whole number. All right? So with that in mind, all your job is right now is please just practice. All right? It's not that much. All right? Look at the one before that to do the even. If you forgot something, look at the odd. They're supposed to be kind of similar. All right? Does anybody have any questions? All right, good job today, guys. You got